The Fibonacci sequence has been around for over 800 years. It is a mathematical sequence that shows up in many parts of God's creation. If you take a closer look at certain parts of nature, you will be able to spot the Fibonacci numbers. You can find the Fibonacci numbers in flowers, pine cones, sunflowers, pineapples, and even artichokes, just to name a few. You can also find the Fibonacci numbers in many other areas like art, the Greek and Roman architecture of long ago, the architecture of today, music, and even astronomy. Today we have with us the medieval mathematician Leonardo of Pisa.
My friends, they call me Fibonacci.
Mr. Fibonacci, how did you come up with the sequence?
I had to come up with a solution to mathematical problem about breeding rabbits.
About what year did that happen?
That was in the year of our Lord, 1200.
Well, thank you for this interview and your information.
You're very, very welcome. And by the way, I had nothing to do with that leaning tower over in Italy. Ciao.
Now let's take a look at the actual numbers of this infinite sequence. The sequence builds by adding two numbers together to arrive at the next number. But just how do these numbers come into play with all of the examples shown in the previous slides? As you can see, this flower contains one petal. 3, 5, 8, and this one even has 13. Spotting the Fibonacci numbers in other plants is a little more involved. You have to count the helices that spiral around in one direction, then the other. I'll demonstrate this for you by using an artichoke. If you noticed, I marked a spot where we can start and follow the yellow lines spiraling this way, counting 1, 2, 3, 4, 5, and we're back at the start. 5 is a number on the Fibonacci sequence. Now I'll go the other direction following the black lines. 1, 2, 3, 4, 5, 6, 7, 8, and I'm back at the dot. 8 comes after 5 in the Fibonacci sequence. You can see that the same would happen for even a pineapple. If you find the bottom and you can count spirals, there is much balance and symmetry to these plants as God planned it. These images show even more spirals found in pine cones and in sunflowers. The golden ratio is made by using the numbers of the Fibonacci sequence to represent the length of the sides. The result makes a rectangle that is very appealing to the eye. You can see how even ancient architects use these proportions in the construction of some famous landmarks. Upon further examination of the golden rectangle, you will also notice a smooth spiral which crosses the center of each square in the rectangle. This is the same proportional spiral that you'll find in nautilus shells, ram's horns, and staircases. The Fibonacci sequence is evident in so many areas of God's creation that one could even say, it's like God's fingerprint is all around us. Thank you for watching.